Hey guys, welcome back to the shop. It's an exciting new tool day for me. We have a couple of vices here for our CNC mill that I'm excited to get unboxed, to get them out. Let's check these guys out and hopefully get them set up on the mill very soon. So over the past couple of months, we've been working on and developing our first A-Bomb 79 product, which is the drill index, and hopefully you've seen some of that footage. We have video out there on the channel if you have not, so please check it out if you haven't. And up until this point, we've always used our standard 6-inch milling vices. I have 2 of them on the mill right now, and that's what's been helping us get this work done. During the batch of the first 100, I was trying to think about ways that we can improve our efficiency and get more than just the 2 work pieces on there. So I thought maybe let's invest in some of the dual station vices. And that's what we have here is the TMX 6-inch dual station vices. This is going to allow us to mount up not just 2, but we'll actually have 4 work pieces that we can load up in the machine now, and hopefully that's it'll push out our cycle time overall, but it'll be nice being able to go to the machine, open the doors, and you've got 4 completed work pieces there. This is the direction that we went, and I'm really excited to get these checked, get them out of the box and inspect them, and hopefully they're going to work really well. I've seen these vices for years now. Other people have shown them and used them and have invested in them. I've never really had a need to invest in this style of vise until now, and so that's why we've gone forward with this, and hopefully this is going to be a really good payoff for us. I think that there's even room to maybe add a 3rd dual station vise in the mill as well, but I want to start with the 2 and see how that's going to work for us, get them set up. I've even got some extra, we've got some new jaws that we're going to be putting on here. I've got some Mighty Bite jaws that we'll use for Op 1, and then I've got some of the snap jaws for Op 2 that's going to be used on these 2 vices right here. So we'll pull those out and show you that stuff as well. But I'm not exactly sure how these are going to be mounted to the machine quite yet. It's very possible that we might have to make a sub plate for these to mount on. Not sure. So let's just go ahead and get them unboxed, check them out, and see where we got to go from there, okay? I did want to add that I have enjoyed every tool that I've gotten from TMX. I think they're a really great, high-quality brand. A lot of their tools, like their collet chucks, are made in Poland, and they're lathe chucks there as well. Now, some of their tooling is made in Taiwan, and that's where these vices are made. So, I just want people to be aware that these are Taiwan-made vices, but every tool that I have used from TMX that is made in Taiwan has been top quality. It's been high quality. I've had no issues with it whatsoever. And I feel confident that these vices are no different. That all the lathe chucks that I've used, all of the collet chucks that I've used, the collets, everything from TMX has been very high quality, and I have no problems investing it for our shop right here. And I buy these through KBC Tools and Machinery, so if you're interested in some of the TMX tooling, please contact KBC, and they can hook you up with the same exact tools. So how about we go ahead and get these guys unboxed and check them out and see where we got to go from there. Operation manual. We got some boxes. Let's see what this stuff is while we're going into it. Okay, these look like hold down clamps right here. Yep. So we got 4 hold down clamps. So these look like toe clamps that you'll be able to use to clamp down to the side. Okay, so that's good right there. I didn't even know that they came with that because I didn't see those on the website. A couple of wrenches. It looks like an extension for the vise handle. Probably some hold down bolts. I'm not quite sure what that is yet, but I'm sure we're going to find out very soon. Let's just move this stuff over out of the way. Exactly what it is. There's your vise handle. Looks like it's black steam oxide coated on the outside. And then we have our vise left here. This guy is pretty beefy and heavy, so I think I'm gonna try the, tell you what, no, I was gonna roll it. How about we just cut the box and just kind of unfold it out of there. About like that. There we go. I think that's gonna work good. We're just gonna finish cutting this plastic. Beautiful. That is a nice looking vise. Nice looking vise right here indeed. Keyed in 2 axes there. We'll be taking these keys off, but so remember on our mill we're using a Saunders fixture plate there, so we won't be using the keys. We're just going to be clamping it down, and since it did come with the toe clamps, that's probably going to be the most simplest way of getting these mounted on the vise. Faster too, so I'm not having to design and machine a subplate for these guys. I'm not sure what these holes are for. I don't think that's going to be for mounting, so I think we're just going to be utilizing the toe clamp method for holding this down. Let's go ahead and I'll pull these guys out again so we can check them out. All right, so there's your toe clamp, and it looks like the way they've got these machined is that you'll just clamp this guy down. Well, all right, one of the problems I see is that the bolt this is going to be too big, and I'm sure this is a metric bolt. I'm not sure what size offhand. It looks like maybe 14 millimeter. I'm not sure, but we will have to replace the bolts for these with half 13, because that's what our fixture plate's mounted machined at. So get the 4 toe clamps to hold it down, and I think that we're going to be in business. My first impressions is that we have a very high quality vise, which is exactly in line with all the tooling I have ever gotten from TMX. Everything is high quality. The grinding finish on it looks good. I'm sure it's going to be an excellent vise, and I can't wait to see it in operation. So we'll get you some closer shots of this as we get this set up and get it ready for the mill. I'll pull you in, get you a nice close shot so you can see the way the finishes and everything look on the vise here. All right, as I said, the first time I've ever seen and used one of these type of vices, so I went ahead and referred to the manual here. They've had some really good instructions. It's pretty easy to read with some diagrams, learning how you can use this. And I'm glad that I looked in this because I'm learning some things already. I was thinking that the work pieces had to be the same exact size in order to clamp efficiently, and I was wrong. You can actually use two different size work pieces in this. But just to quickly kind of go over, when I first opened it up, I noticed this is considered moving jaw 1, this is moving jaw 2. You see it opens up approximately 3/8, and then it starts opening up the rear. So whenever you're changing out your work pieces, this is what's going to be normal. But in order to get the moving jaw 1 all the way forward, you have to, this is just when you're setting up, by the way, so you have to move the rear jaw all the way to the back, and then it's going to move the front jaw all the way back until you get it positioned where you need it to be. And then once you get it positioned, it's going to close up the rear jaw. Just imagine the work pieces in here. I'm sorry I didn't grab anything to show you, but it'll clamp the rear work piece, and then it's going to bring in the front jaw. There is just a little bit of tension on this right here, but that's okay. It feels good. And then so then it'll clean up, it'll tighten up on the first jaw. So when you go to loosen it, it's going to loosen the front jaw, then it's going to loosen the rear jaw, change out your work pieces, and then it's going to tighten up the rear jaw, then finish tightening up that jaw right there. So a couple other things that I have figured out that you can do with this as well. I didn't realize this going into the vise. So this is obviously your removable jaw. This is a fixed jaw. You can unbolt this and have the entire length of the vise available to hold larger work pieces there as well. In the book, they do show that you can of course machine your own soft jaw to go in the middle here, but they're showing how, you know, you take this out and you can have a machinable fixed jaw that goes in here, machinable jaws that go in here, so you can have your entire soft jaw set up right here where you're holding two work pieces. So that is pretty cool right there. And there's other features as well. I've just got to get a little bit of time and go through the book and read it, but it does show you everything about the vise and how you can use it. There's your machinable jaws that it's talking about right there, and different ways that you can set up and use it. So again, you can have different size work pieces in this. And then they got their inspection there at the end. The one that I was really curious about is the parallelism, running face to the bottom of the bed. They inspected it as being 1/10 out of parallel. So that should be pretty good right there. I may even do some of my own inspections just to verify that and see, but I have no doubt that this is that it's ground to within tolerances is going to be good, and this is going to work well. All right, so we're going to just repeat that with the second box. No point in showing that. It's going to be the same exact thing, and I'll bring you guys back whenever we move on to the next step of getting these inspected and set up. Okay, I went ahead and grabbed all the hardware that we got to go with our new TMX vices here. I wanted to show that to you going in. So right here we have, these are all the Mighty Bite Talon Grip jaws and the Talon Grip inserts. These are what you've already seen me use these because we have this set up on our current vices. I wanted to have sets of these jaws to go with the new vices, so I'm not taking them off one vise and putting them on the other. We just have enough jaws to go with every vise that we're using on the CNC mill. So anyway, these are the jaws right here, and these are going to be your Talon grips. And I go with these 2-inch length Talon grips right here. They have the serrated edge on there, so they bite into your workpiece very nicely. They go up here on the Talon grip jaw, so you can mount these anywhere along there that you want. They work really good. So this is the setup that we use for Op 1 when you're biting into your raw stock. This is what holds that. Do your Op 1, machine everything. And then when we're through with Op 1, we're going to be reconfiguring the vices to these snap jaws over here. All right. These, I went ahead and got the 3/4 step. These are the jaws. They have a lot of different jaws that they offer to the market. These are the step jaws. We'll just go ahead and pull them out of here so you can see them. And this is the 3/4 step that is built into these jaws. They're supposed to be matching pairs. They're supposed to be very accurate. And once these Talon grips come off, you put these screws in there and you basically just slide these jaws over the head of those bolts, and it comes with a wrench so you can reach in there and snug them up. These are going to be used for finishing the drill indexes op 2 once we flip them over. So we went ahead and just got 4 complete sets, so that'd be enough for both of the vices here. And there was one thing I was going to point out here as well. On the Talon grips, whenever you buy these, they come with set screws. And this stop right here, let me just go ahead and pull it out of the bag. So this is just this little guy, this little T-shaped piece is just a simple stop. Any of these screw locations, you can put this guy in there and bolt that down, and this is your built-in work stop. I believe we're going to start utilizing this guy here for our op 1 and do away with the mounting, the stops that you bolt onto the table. We're going to give this a try and see if that'll help us out and save a little bit of room and clutter onto the machine itself. So we're real excited about this. Hopefully this is going to be a new and improved setup going forward, machining our drill indexes, or for that case, any work that we decide to put into the mill to use these vices on. Okay, we have our new TMX vices up here on the Starrett granite surface plate. We're just doing some inspection to see how parallel the vice beds are. We've already got our Gorilla stand and our Starrett test indicator set that we are using the number 708 Starrett test indicator. This is a 1/10,000th or a tenths indicator. And I'm just going to add that sweeping parts like this is always a little bit fidgety with these little tenths indicators. So it's common for me to get about a 1/10 difference on the indicator. That's not exactly a true reading, but I think we've got it there so that we can share this. If we just slide up on our bed there, and this is the one that I started with, and I've tried to get it set to a 0 as close as we can. You're off at a little bit of an angle, so it's going to look a little bit skewed, but that's looking pretty good. So let's go ahead and sweep all the way across to the other side. And if I see if we move it a little bit, we're showing about a 1/10 difference in movement. So that looks pretty good right there. So this side is showing about a 1/10 lower than this side. Remember, our book said that it's parallel within 1/10. So we're going to see if I can kind of mimic the same readings. Seeing about a 50 millionths difference just across that surface right there. All right, now we're going to slide back here to the back side. Come in here and so that side right there, I'm getting approximately 2/10 low. Just do a little sweep here and see if it changes. A lot of times the indicator will move about 1/10, just moving things around because it's just the nature of the beast here. And you can see the movement just going across. That's as far as I can get right there, by the way. So I'm getting, on my reading there, about 2/10 difference. All right, so I'm just going to call that one 2/10 back there. So I'm measuring this particular vise without coming out here and measuring this area, probably within 2/10 of it being parallel. Back this back across here, you can see the indicator change there. That's what I'm talking about. You move it around a little bit and it usually kind of settles in. That's showing about 2/10 as well. We come back here to the front side and sweep it again. Let's see if we still line up on our 0, and I think we are. So I believe this particular vise is measuring within 2/10, which is 1/10 off of what the book says. I may be getting some error in it, so I'm not saying that this is absolutely dead nuts perfect, but I feel like I'm getting 2/10 difference with my readings. All right, so I think we're going to move to the other one. I'm just going to go ahead and wipe the granite plate off, get rid of the dust that settled since we wiped it last. And we'll go ahead and bring our gauge over here. And I feel more comfortable on that other side. I'm going to come back around here. Let's just start back there and see. That is lining up very close to what we first measured on this other vise, so really, really close to our 0. That one's looking good. Looks like it's raising up about 1/10. Maybe a little bit more than that, 1.5 tenths. Okay, let's pull back. Let's come over here and see what this side's measuring. About a 50 millionths, almost, well, let's just call that 1/10 over the 0 there. Come across and see what we're measuring. Pretty close to 0 right there. Well, I think that this vise here is actually measuring just a slight amount better than the first one that we were measuring. I'm just comparing the difference. So this one appears to be close to that 1/10 tolerance that's called out on the spec sheet. Except this side's raising up just a little bit more there. So I would feel comfortable calling both of these vices within 2/10 of being parallel all the way across from one side to the other. Definitely close enough for what we're doing, but really just checking the accuracy of what the manufacturer says that the vices are machined or ground within, you know. So I think that's pretty good. We're just going to roll with that. And it's always fun getting out your precision tools up on the granite plate and getting to do a little bit of comparative measurements, a little bit of inspection work. It's just fun. And I think we have some nice vices on our hands right here for the milling machine. All right, we're going to get these vices set up. I'm going to get these two off. I'm using my sky hook for this to pick up the heavy loads. I wanted to show this right here since we lifted the vise up. It's been a pretty good while since I've taken this particular vise off, and you can see what looks like, you know, a little bit of rusting down here. You have a little bit of oxidation coming off the bottom of the vise, but you can see it wipes right up. And that's because what I do whenever I clean these tables off, I always coat it down with either the SP350 from CRC. The 336 works really well also. Either one does a good job. The 350 is more of a long-term rust inhibitor, where the 336 does a lot of, is great for, you know, multi-lubricant applications, needs and things like that. But it's not, you can see what I was getting at, it's not really rusting the fixture table. If we wipe it, you can see it's like there's rust that'll sit right on top of the rubber there, right on top of those little rubber caps, and it's the metal sitting on the rubber that rusts, and that's why it makes it look so bad. But that SP350 has done its job and helped protect this, keep it lubricated. So I'm going to get this table cleaned up really nicely, blow everything off, clean it really well, and we'll coat it back down with our SP350 and get ready for the new dual station Vises. You see over here where our G55 work vise always is. You really don't even see any of that rusting on top of these caps right there. Just the longer they sit on here, the more you'll get a little bit of that rust down there, but that lubricant does a good job on helping to prevent it and prolong the life of your tools. We are ready to put the vices on here. Give it one more wipe down. I don't know exactly where the vices are going to live yet. I'm going to have to just get them on here, put some work pieces in here, and get things positioned the way they need to be. All right, we're going to give it a really good coating with our SP350. We'll make sure the bottom of the vices are cleaned off as well with our towel, and then spray it down with some SP350 as well. That squeaking on that sky hook is inside the gearbox. I'm not really sure how to get in there and lubricate that with this being a closed sealed unit. It's going to be a pretty close fit in here. Luckily, whenever we close it up, these guards, the chip guards there, that's all these are, will go in, because we're not going to be retracted all the way out like that. We can get it right there. It's going to work pretty good. All right, let me get the other one in here, and we'll figure out where our vices are going to live. I am using this what they call the vice hook from Skyhook. It is made to adapt to 6-inch and 8-inch vices there, and it says it'll lift 500 pounds. This is going to take me a little bit of time to get figured out, because I'm actually starting to have clearance issues. I know that the vise wasn't too long to fit on the machine table, but it's actually really close. In fact, these guards right here, you have a guard, you know, a chip guard that goes all the way through there, and the way that they're sticking out there, is this chip guard on the back side would be sticking out past the edge of the table, and I actually need to get the vise moved that way a little bit more. I've already moved it over there against our way guard, because what I have to keep in mind is that when we go all the way over that way, you can't crash into the way guard, can't crash this, but I'm also need enough distance so that the cutter can come all the way over here to this outside edge and be able to machine this there as well. It's going to be really, really close. I think that's what's happening, is it's really close. This is a 16-inch travel. I think that the next mill that's coming, the 3018, this is going to be, you know, perfect for that setup, because that's going to give us an additional 2 inches on this table here. And this is that machine that's coming is what this setup was intended for. But I'm trying to make it work here on the tool room mill to get this going, because I want to be able to machine 4 of them. So anyway, what I was saying is that I'm going to go ahead and work on this off camera and try to get this configured where it needs to go. What I'm thinking I'm going to have to do to make this work is get our material in here and, you know, clamp it in there to see where it's got to be for our stock. And I'm probably going to have to go ahead and maybe cut off a little bit of this guard on the back side. It probably won't need it up here, but the back side, I'm going to have to draw a line across there and take a cutoff wheel and cut that off to get it as far back as we can. I really need the vise to kind of go back to where it's almost flush with this table, and I know that's going to bring it up very close to the way wipers there. I think I'm going to have to do that in order for our end mill to come to this side of the workpiece and be able to cut it. So I'll get this figured out. Hopefully we can make it work. Bring you guys back when I have it there. Okay, I have been assessing the situation here, and I think I have come up with a game plan that's going to help me in the future for the setup. I believe what I'm going to do is go ahead and remove the dual station vices, because there's some additional work that I'm going to have to do before I can use them over here on the TRM. The problem that I'm having is how much space we have between the work pieces right here. You really only need the width of like one of these jaws, you know, so we can get our 1/2 inch end mill around there to finish this. But this gap right here is pushing this work location out far enough so that whenever we go all the way in, I'm going to go ahead and just hand wheel it all the way in there. And you can see I just bumped this one right there. That's the other problem I'm having. These guards are sticking out on the back side, and I have to be sure that these vices are positioned on this table and the guards don't stick out to where they're going to crash into my way guards for the Z axis. All right, but we've got that all the way back right there. And then with these guards sticking out, that means it's just that way guard back there. Let me see if I can reposition that. As the head goes down, these guards are going to come down and they will crash into this if this is sticking out. So where are they going to be positioned for my workpieces here? I'm going to have this guard on the back side cut off there evenly. Okay, we're going to have to do that in order to get, I need every ounce of Y distance on this machine that I can get in order to use these dual station vices. All right, I'm going to bring it back. And what I'm probably gonna do is we're gonna build our own custom center jaw right here. So you can see over on this one, I don't have the jaws bolted to it. So we're gonna take and we're gonna machine our own center jaw, and it's gonna be machined exactly like these Mighty Bite jaws right here. We'll be able to take our 2 inserts and bolt them right in the center of this jaw. So our talon grips aren't going to come all the way out to the edge, and I think that's perfectly fine though. We're going to have them more in the center of the block for this jaw right here. So by eliminating this jaw and this jaw, it's going to allow this workpiece to go back. It's going to allow this one to come this way as well, and this one go back. It's going to tighten up our envelope that we need to be able to machine both of these parts right there. So that's my plan. I think it's going to work. I've been trying to think through this the best I can, and I think that's going to be one of my best options right there. So because I'm going to have to work on these vices, we've got to machine a couple of jaws. I'm going to pull these back out of the mill. I'm gonna put a couple of my other vices back on here and get rolling on my parts here, my drill indexes, just like I was, because I need to continue getting these guys machined. So while the machine is over here machining some parts, I can get my jaws modified, get these vices modified to where I think it's gonna work. And when I get to that point, we'll break the setup down and bring them over here and see if we can prove them. I believe that once we get our new mill in the shop, these vices are gonna go over to the new mill, the VM mill, and it should be just fine. We're gonna have an additional 2 inches of Y travel on there. And with the modification we're gonna make, I think we're gonna be able to just put it on there, get it centered up like we should, and we should be able to roll from there. So the project's taken a little bit of a change that I wasn't expecting, or what I wasn't thinking it was gonna. I knew that the device would fit on here, but I didn't take into consideration where this workpiece would be in relation to our Y-axis. I just need more travel out here, and I need these vices to be able to go all the way to this back edge of this table, and the guard back here is preventing that. So more work to do, but I think it's going to create a good project, and I'm going to get the camera and share with you guys machining of these jaws right here and see if we can get this problem solved. Here's an update since that last video clip that you just saw. Since we had to take the dual station vices off, we went back in with our standard 6-inch milling vices, but this time I went ahead and added a third. I got this Kurt vise over here, and I've got our table loaded up to maximum capacity based off the width of our workpiece and having enough room to get to the outside, you know, in our X travel there. So this is working great. The first batch that we machined of our drill index, I was doing 2 at a time. So the fact that I can do 3 at a time now is increasing my productivity, and it's allowed me to get through these a little bit faster, and it's working really well. In addition to that, I have made a couple of changes to Op 2 from the first batch. We have not put the 2 drilled holes in it like we did the first time. The drilled holes were only because that was required by the anodizer at the time that was doing the samples. He needed a couple holes drilled in there to put the little spring clips to hold them in place. The shop that they're at now, that's doing our testing, at this time, I'm still waiting for our new samples to return. Hopefully it's going to be within the next couple of weeks. We're going to have all of our samples back. And the way that they are going to hold our pieces, instead of having them drilled or drilled and tapped, they're actually going to catch them on the inside of the radius here on the bottom of the legs. And they said that there may be a very, very small, minute dot on the inside where the anodizing doesn't get on there because of the way that they're going to hold them. But allowing them to hold them in that way is going to save time and cost of the anodizing, because they said in order for them to rack them, otherwise they're going to have some drilled and tapped holes to be able to bolt them onto the rack each time. So we're trying to reduce the labor. We're trying to reduce the cost, the overall cost of it, and hopefully when we get them back, they said on the clear coats you won't even be able to see it, but on the color anodized, you may see a little dot on the inside of that. I don't think that's a big deal because this is the bottom of this, and we're documenting this entire project through its journey, so you guys will be aware of it if it happens, and once we get our samples, we'll be able to see. So this 3-part setup is working beautifully right now, and I also wanted to let you guys know that I have worked on the program. I sat down with Kevin at Mechanical Advantage. He's the one that's been helping me with this project, and we sat down and I wanted him to kind of show me some ways that I could help optimize the tool pass and speed up productivity, reduce the amount of cycle time. So one of the big changes that we made was our clearance height and our retract height on our tools. So now I have every tool that's coming down here doing the work is only lifting up a couple hundred thousandths above the part before it moves over to the next one. We have a clearance height whenever we're doing our cleanup tool pass of 8 thousandths, so it's only lifting 8 thousandths before it comes back down to cut the next tool path. But between parts we got about 200 thousandths in clearance, so we're not seeing the tool lift all the way up here over and then all the way back down. So that's speeding it up there as well. I know a lot of guys saw that, and I appreciate the feedback on things that we can do to kind of improve our cycle times here and overall just, you know, become better machinists at what we're doing here with our CNC machines. We have all of that in a previous video, so if you haven't seen the drill index machining, check out the 2 videos. We have one for Op 1, we have one for Op 2, and then we have another video showing the anodized samples that we received first. So I'm going to keep working at these guys. I've been slamming my way through Op 2 with our second batch of 100, and we're about halfway through with them right now, and everything's working really well. Real happy with it. So that's the update that I wanted to give you here, where we're at on our 3-vise setup on the Miltronics TRM. So what I believe we're going to do with our new TMX vices to help us out with this situation that we have on basically kind of running out of Y travel, we're going to go ahead and remake 2 new center jaws that are going to mimic the same style, height, and everything of our Mighty Bite jaw. So if you'll just kind of imagine this jaw being bolted down in the center where this guy is, with the exception of, we're not going to worry about any through holes on the side where it mounts into the, each end of the vise. We're just going to make a jaw. We'll make 2 of them, same height and everything. We'll probably go ahead and make both sides, like where the parallel is, the same width. But instead of it bolting onto the side, we're going to use these 2 hole locations here, and we'll have it drilled in counterboard so that we can just use a socket head bolt to bolt it down. And then we will move our talon grip jaws to the center here. I'll have it so that they'll just be bolted right there in the center. And that's going to be perfectly fine for holding our rough stock for doing the machining. And that way we can have this guy in the middle right here. And that's going to allow us to have our outer workpiece that much closer in here, gaining that much distance on the side where our cutter can come around here and get to the back side of the cutter. So with doing that, and unfortunately cutting off this amount of the chip guard right there, we're going to have to do that as well, because you see that's a little bit over 1 inch that we need to be able to go all the way back to the Z-axis chip guard with enough clearance that this doesn't hit them as this is raising and lowering there. So we need to modify this. We're going to cut it just as simply as short as possible, machine 2 new center jaws that are going to look like the Mighty Bite jaws that will hold the talon grips in the center. And I think that is what I'm going to have to do in order to be able to use these efficiently. And I feel very confident that's going to work, and that's going to work well. So that's the plan. I'll bring you guys back and we'll make a video out of machining these jaws right here. Most likely just do that over here on our KBC mill while the Miltronics is back there running some drill indexes. So again, we'll bring you back and show you that project and how we make out with our new TMX dual station vices. All right guys, I've been editing the video that you're seeing right now, and this was kind of like a monumental moment for Abby and I in the shop. This is drill index serial number 200, which is sort of a big step for us. This kind of represents sort of the end of the first big push in the machining of the drill indexes. We still have a lot to do, but it's really exciting to see this point right here, to get to this point. And if you look on the back, you can see serial number 200. Very cool. And then behind us on the table right here, these are actually the final 3 of what I'm considering the first 200. So we got 201, 202, 203. I'm getting ready to put those guys into the Miltronics right now, and that'll finish up the machining of the first 2 large batches of these guys. And it is really exciting to see this happen, and I can't wait to get them anodized, and I can't wait to get them to all of you guys out there that have shown so much interest in these things. Abby and I are both really excited about this. I cannot wait to see what you think about these whenever you have these in your hand and you have them on your toolbox and you get to enjoy them for yourself. So anyway, I just wanted to share that moment with you, and maybe it put a smile on your face like it's done Abby and I's around here in the shop. So I'm gonna get back to work and get these last 3 finished, and we'll see you on the next video.